Next week, we won't get all the way through this section today, but we're going to do the first part. So antiderivatives. We have spent a long time doing derivative stuff. And all things related to derivatives. We start out with limits and continuity and all the things you had to have in order to do a derivative. Then we had all of our derivative rules. Now we have to go backwards. So this is just kind of giving some motivation. If you have a physicist who knows the velocity of a particle, you might wish to know its position at a given time. That seems reasonable, right? If you know how fast something is moving, might you want to know where it's at a given point in time? Or an engineer. You can measure the rate that water is leaking from a tank. You want to know the amount that has leaked over a certain period of time. That seems reasonable. Or think about like an oil spill. If you know how fast the oil is coming out, you would probably need to know how much oil has leaked at a given point in time. Or a biologist might know the rate a bacteria population is increasing, and therefore might need to know the size of the population at a given point in time. So all of these things, if we know the rate, that means we know the derivative. If I'm trying to get back to the population or the amount or the position, I'm asking for you to go back and find the original function. So that is an antiderivative. So an antiderivative, notation they typically use capital F, is one so that if you do its derivative, you get your function back. Okay, so it's what the equation was before we did the derivative. So let's see if we can figure one out. What would be the derivative or the antiderivative of x squared? So what happens when you do a derivative?
The exponent comes down.
The exponent comes down and you subtract 1. So if I'm doing the antiderivative, what should I do to my exponent? Add 1, so it would be a cubed. Okay? But the derivative of x cubed is 3x squared. Right, we have to do the reciprocal in front. So 3 times the third would be 1x squared.
Okay.
Alright, so there's the antiderivative. Now, is this the only one? Is this the only function where the derivative would be x squared?
You can have like a +1 on the end.
Okay, constants have a derivative of 0, right? So it could have been a +1. Or it could have been a -7, or any other constant, added or subtracted on the end, and would still give us the same thing. So the antiderivatives, it's not unique. They're all the same except for a constant. So when we do our antiderivatives, we're typically going to write +c on the end to show that any constant could be on the end of that.
So everything will have a +c on it.
Mm-hmm. And in terms of, this just shows you the graphs of a lot of different ones. You see that it's all the general shape. All that constant does is move your graph up or down. But the derivative, the rate of change would be the same at any given point in time.
We're gonna blow away.
Yeah, I might have to close my windows. All right, so let's see if we can figure some out. What will be the antiderivative of sine?
Cosine.
Okay. Why is it a negative?
Because cosine is, because sine, the derivative of cosine is negative sine, so negative times a negative.
Good. Now, what else do I need?
+c.
Alright, and the nice thing is you can check. Because if you did the derivative of negative cosine, you get the opposite of negative sine. Derivative of c is 0. Is that sine x? Yes, so you can check your antiderivatives by doing the derivative. B. My function is 1 over x.
Natural log of x.
Yes. The natural log has a derivative of 1 over x. What would you need on the end?
Okay, never mind. This is not as bad as I thought it was.
Seems so dramatic.
Well, hey, the c though.
What if I said x to the n? So n could be anything. I'm trying to find a formula for that. So when you do the antiderivative, what would happen to your exponent?
Come down.
You
Or
would add 1. And then what would I need in front to cancel that? 1
over c.
Oh, okay. And then we just have our plus c on it. Because in the derivative, the exponent comes down, so you put the reciprocal in front.
Is it saying it's not 1 tells us that we have to add 1?
Mm-hmm.
Okay. So if it were like a not 3, we add 3.
Okay. So I included a table out of the book, just know if you're looking at the book, it gives you a bunch of different antiderivatives. Not necessarily ones you have to memorize, but these are just things that we know already from our derivative rules. So if I asked you to find this antiderivative, just like when we were doing derivatives, it might be helpful for you to write things as all x to a power without radicals. So 3 square root of x would be 3x to what power? Minus 4 over x squared. So if I did my antiderivative, just like when you were doing the derivative, you went term by term and did the derivative of each term. So we did the same thing when we're going backwards. What is the antiderivative of x cubed? Okay. The 3 is a coefficient. It's just going to stay. Think about your x. If you add 1 to your power, so what would have to go in front?
9.
Yeah. So first, just
Oh,
think of it as a reciprocal. And so then it just gets multiplied with the 3 that's already there. So it's just actually a 2x to the 3 halves. Do you guys see that? You did the derivative, 3 halves comes down, times 2 is just 3x to the 1 half. Alright, so here, minus the 4 we're just going to hang on to for a minute. Think about our x. If we add 1 to the power, it is?
Add 1, negative 1.
So what goes in front?
A negative.
So we get plus 4x to the negative 1. And what else do we need?
Just a skosh. I gotta write out this word.
Just a skosh.
I'll never remember what we did.
You guys want to try one?
Yeah.
Take a second, see if you can figure this one out. So if we first rewrite x to the 5 halves, how would you write 5 over x to the 4?
Negative 5x to the negative 4.
Minus a square root of x. We do our antiderivative. So you add 1 to the power, so 7 halves. So you have to put the reciprocal in front. 2 sevens. Alright, this 5 is just going to stay. Add 1 to the power, so negative 3. Reciprocal in front. Add 1 to my power, so 3 halves, reciprocal in front. And then we do a plus. So we get 2 sevenths x to the 7 halves plus 5 thirds x to the negative 3 minus 2 thirds x to the 3 halves plus. How'd you do? Missed a negative. That's minor.
That's only half a point.
Yeah, see? Let's try this one.
Hey, it's okay.
Okay, let's think through this. So, the 2 is a coefficient. We're just going to hang on to that for a second. Alright, what has a derivative of cosine? Derivative of sine is cosine. Okay, when you do the derivative of a trig function, derivative of sine is cosine, the angle would stay the same, and you would multiply by the derivative of the inside. What's the derivative of 3t?
T to the third.
3. So what would I need to cancel that? 1/3. So we have to think about our chain rule in reverse here. So I'm multiplying by the 1/3 so that when I do the derivative of my sine, get my cosine, derivative of the angle is 3. I multiply by the 1/3 to cancel it. Okay, and just keep this 5 for a second. What has a derivative of sine? When you do the derivative of the trig function, angle stays the same, but I would have to multiply by the derivative of the inside, which is 4. So to cancel that, we need so we get 2/3 sine to the 3t minus 5/4 cosine of 4t plus c. And if you weren't sure, how would you check yourself?
Do the derivative.
Do your derivative. You guys do the next one. Alright. So 2 would just stay. What has the derivative of cosine?
Sine.
When you do that, the angle won't change, but you would have to multiply by the derivative of the pi x, which is pi, so to cancel it, you need 1 over.
Oh, the x goes away.
Yeah. Think about chain rule.
Yeah.
So 3 would stay. What has a derivative of sine?
Negative cosine.
When you do that, the angle won't change, but we have to think you would multiply by the derivative of the angle, which is pi. So to cancel it, we need 1 over pi.
So why do we cancel the inside of that?
Okay. Think about when you do the derivative of this. So if you had -3 cosine of pi x, and I asked you to do the derivative. Derivative of cosine is negative sine. Angle stays the same. Chain rule. Derivative of pi x is pi. I don't want that pi in my answer, so I have to have a 1 over pi in my antiderivative to cancel it. And then of course we need the plus. So we get 2 over pi sine of pi x
Oh, that. Okay, well.
minus 3 over pi cosine of pi x plus c.
That said, I could just change my angle.
Oh, well,
Okay, you know, get rid of that x.
yeah, sure. Okay, so we're doing chain rule in reverse there. Let's try to do a few more of these today. Okay. We could multiply this thing out 10 times. That seems bad. But just a heads up, like if I had something like this, do we have a way of doing the antiderivative of a product? How do you do the derivative of things being multiplied? Product rule, and we'd have to do chain rule possibly within it. We don't have a rule to undo the chain rule, right? So if I asked you to do the antiderivative of something like this, we would have to multiply it out first, and then do the antiderivative term by term. Now this one, since it's written as like a chain rule type problem, not a product, we can think through it. If you were doing the derivative of this, what would you do?
10 out.
Okay, that exponent would come down, subtract 1 from the power, right? So let's undo that piece. So we add 1 to the power. So that means we need, okay, then, so think through your derivative. Exponent comes down, inside stays the same, subtract 1, times derivative of the inside. It's 1. So do I don't really need anything to cancel that. So it's just 1 over 11 times x plus 5 to the 11 plus.
I thought too hard.
Now, if it had been like a 3x, what would I have to multiply it by? 1/3.
Why did my pen just?
All right, you guys try this one then. So this is 3z, we could write as 3z plus 10 to the,
-7.
okay, so when I do my antiderivative, we add 1 to the power. So -7 plus 1, -6. So when you do the derivative of this, the inside would stay the same. You would bring the exponent down, so what do I need in front?
-1/6.
Inside stays the same, subtract 1, times derivative of the inside. What's the derivative of the inside? 3. So to cancel it,
See, I thought it was 1/3, but then I thought it might have been 1/4, because I was just going too hard.
and then positive 6 since it's negative, and you can consider the denominator. I don't know, I was totally thinking that.
I always thought, for some reason, I was
Because I was thinking like it would be like a fraction of like 1/6 times like 3z
Okay.
plus 6.
You could write it like that. That would make the exponent positive, but that negative still stays. So you were saying you thought of this like
Yeah,
that.
and then so then I was like, if it has to cancel, then the 6 has to go up, so then it would be like a.
I'm not sure I'm following.
Okay. I don't know what I'm saying there.
We'll see how far. Okay. So find all functions g such that g prime is equal to this. So here's the derivative. Tell me what g was. Okay. But let's clean this up. If you had to do the derivative of this thing, what would you be stuck doing?
quotient rule.
Quotient rule. Have I given you the opposite of a quotient rule?
No.
No.
X to the negative 1.
Okay, so let's clean this up first. So we have 4 sine x. You can bring up an x to the negative 1. Can I go ahead and just... Okay, so if you bring up an x to the negative 1, you would still have to distribute it through, right? So it's really just subtracting from your power. So that's 2x to the 4th. This is x to the 1/2 times x to the negative 1, so x to the negative 1/2. So simplify before, just like it was way easier to do the derivative if we multiplied or divided things out first, it's way easier to do the antiderivative if you clean it up first. So then the antiderivative. What has a derivative of sine? And the 4 would just stay. Can I just go ahead and write it as negative 4 cosine x? Alright, so here, if you add 1 to the power, it becomes 5. So you need a 1/5 in front times my 2. Can I go ahead and put 2/5? Is this too much too soon if I'm...
What is the negative 4?
Because the derivative of cosine is negative sine. So you need a negative to cancel it. Okay. Add 1 to the power, negative 1/2 plus 1 is 1/2. So what do we need in front? 2.
Plus C.
Plus C.
It looked scary, but it was really okay.
Good.
So that 4 that stays out in front,
Mm-hmm.
we don't. It just lives there.
Yep, just lives there.
And that 2/5 is that just from bringing the exponent up by 1?
So that's next to 5th, which puts a 1/5 in front, times the 2 that was already there. Last problem of the day. And for some reason it didn't print, but you can clearly see it's there, so...
I thought it was just gonna be like the answer in C.
Yeah, I don't know why it didn't print. It's really strange, but... Find f if the derivative is equal to this. You guys do this problem. So the notation, if your original function is f to show you're going backwards, you go to capital F. If I have it labeled as f prime, then the antiderivative just takes away the prime. So just some different notations there. Alright, so if I add 1 to my power, it would be 4. So I need a 1/4 in front times my 20 would be a 5. X squared, add 1, so it's x cubed, so I need a 1/3 in front times 12 is 4. X, add 1 is x squared, so 1/2 times 6 is 3. And then don't forget,
Plus C.
are these okay? Alright, so, homework time. No. I want you to do 1 through 17 odd.
My book's gonna get waterlogged.
I bet Carson doesn't have his book.